Okay, let's get started. It's quite the title. I worked hard on that. More fun with integrals of rational functions. There are, you ready? 12 examples. Let's just get at it. Some of them are quick though. Okay, number one. Can you find the integral for 1 over x dx? It's a rational function. Can you find its integral? Ethan, yep, what's the integral? Perfect. The natural log of the absolute value of x plus c. Good. You like that? Okay. Number two. The integral of 1 over 1 minus x dx. Be careful. Two. Jason, Miss Julie, is that okay with you? Okay. Here comes number three. I guess what we could do is I could just like go through the test I'm going to give for all of those that are here. Pause the recording and then start the recording with the next set of examples. So for those of you at home, maybe I paused the recording, maybe I didn't. There's a glitch in the time-space continuum. All right, number three. Number three. The integral of 1 over the square root of x dx. This sort of feels like a polynomial type integral. We're just going to do the power rule with this. It's not too painful. So it's x to the now positive 1/2 divided by its reciprocal plus c. So if you want, it's just 2 square roots of x plus c. I'm just kind of giving you all the rational functions that we've had to integrate so far. Gary. No. Number four. Um, the integral of 1 divided by the square root of 1 minus 2x dx. I'm eager to use inverse trig functions, but does this require an inverse trig function? No. Because the truth is, when we look at what's inside of the square root, it's just a very safe linear function with a constant rate of change. So we can manage that. And when we find its constant rate of change, it's just -2. And then we can factor that out. It would be different if we were working with a function that has a dynamic rate of change. So when I rewrite this, it's going to be equal to, I'm going to factor out, I'll rewrite this properly, Mr. Harley. So this is du over -2. I'll just write it as minus like that. That's our replacement for dx. So then you're going to rewrite this as -1/2 the integral of, well, I'll write it nicely. Is it just 1 over the square root of u du? And we kind of already just did that, didn't we? Just sure I don't make any mistakes. And just write it as u to the -1/2 du. So minus the square root, as the 2's cancel, of 1 minus 2x plus c. I'll take your silence as agreement. These are fun. I think they're fun. Number 5. I said we're going to get to 12. We're doing pretty good. It's 11:03. Here we go, number 5. How about the integral of 1 over the square root of 7 minus x squared dx? Should we let Thomas in? Good morning, Thomas. Are you counting colors? Some people.
Raise your hand if you're wearing black today. Thank you.
Hey, how many people wearing purple today? Thanks. All right. Can you see this function within the square root is too dynamic for us? Is it not a squared minus u squared? It's interesting that we do this comparison, right? Because in the previous one, it was just 1 minus 2x. Nice, friendly, linear function. Everything changed, though, when it turned into 7 minus x squared. Because of this change, I'm going to tell you that a squared is equal to 7. So how do we describe a? Square root of 7. And then u squared is equal to x squared. So I guess u is the same as x. Which one of the three integrals, or is it sine? No, it's not sine, it's arc sine. It's got a cool name. I'm arc sine. All right, equals. And then arc sine doesn't have that 1 over a. We talked about that. So it's going to be arc sine, and it's simply what is u? And in this case here, u is x. And what is a? Square root of 7. Very nice. Plus c. Better? All right. Number 6. The integral. Upstairs, you've got 8. But that's a constant, so I gotta admit, I'm okay with the 8 upstairs. That's not gonna bother me too much. Downstairs, we've got the square root of 3 minus 4x squared dx. Find me the integral. So the 8 is not the problem. Is it a constant minus some sort of version of x squared? So can we conclude safely that this is just arc sine? Where a squared shall be 3, so a itself will be the square root of 3. U squared shall equal 4x squared, so u itself shall be 2x. Now I have to be careful. This is what I forget. We still need to generate du. And when we generate du, is it not equal to 2 dx? And if we want to have the proper replacement, do we not need to create du over 2 for dx alone? So it's going to equal the 8 that was already there. And then is it safe to say the 8's going to multiply the 1/2 that we're going to factor out? And I guess if we're going to do it like this, we're going to have to write it as like 1 over the square root of a squared minus u squared du because of that 1/2 that we generated. If we move forward from here, it's going to be 4 on the outside because I'm pretty certain that 1/2 of 8 is indeed 4. And then when I integrate this, it's going to be arc sine u happens to be 2x, and a is the square root of 3 plus c. And I realize I've got a set of brackets in there that I don't actually need. Superfluous brackets. Okay. Number 7. So we are past the halfway point. Here comes number 7. Could you find the integral of 10 upstairs divided by 9 plus 16x squared dx? Hurry up, Jason, you're missing out on the fun. Like, remember the title does say more fun, integrating rational functions. Doesn't arctan have the 1 over a? That's going to be 1 over 3. Is it safe to say it will be like 5/6? You want me to rewrite it? And Neri is fair. I make you rewrite it. It only seems fair that I should rewrite it. So it's going to be 5/6 arctan. Fair enough. Is Kaminsky playing cahoots? You know he's got an account, right? Like he's not just a casual user. Number 8. Just so you guys know, I don't have an account. All right, I want you to consider the integral. Upstairs, you've got 4x cubed. Hello, that's different. You've got a very dynamic function living upstairs. Downstairs, you simply have 2x plus 3 dx. How are we going to manage this question type? So notice, like in every other scenario, wasn't the top of a much lesser degree? Like they were all like, sorry, bottom heavy in a way. This one is top heavy. The greater degree is, what are we going to do? We're going to do long division. Because we can divide now, right? Before we couldn't divide because it was nothing for us to divide by in a way. So if we got to do the long division, you're going to go 2x plus 3, and you're going to divide it out of 4x cubed. Now that's slightly problematic because when you do this, you have to put the 4x cubed, but then we need the dance partners, right? So we're going to have to put in plus 0x squared plus 0x plus, I guess, 0. All right. What do you do to 2x to create 4x cubed? 2x squared. So that's what you write up here. You're going to multiply by 2x squared and make sure it goes in the column. Remember, columns are up and down. That's where the x squareds live. And now when you rewrite this, 2x squared times 2x gives us 4x cubed. And then don't forget about the annoying little brother. That's going to create plus 6x squared. And then you're going to put brackets around it. And then you're going to remember to always subtract. And when you do the subtraction, aren't you now left with minus 6x squared? Then you will drop the dance partner. So now you have plus 0x because you need two pieces to be compatible with your 2x plus 3. And then the question is, what do you do to 2x to create minus 6x squared? Yeah, we're going to have to multiply by minus 3x. Minus 3x times 2x gives us exactly minus 6x squared. Minus 3x times positive 3 will create minus 9x. And then you'll remember to put brackets around it, and then you have to subtract. And when you do it this way, you'll create positive 9x. And then you need another dance partner. That's interesting. This is way easier this way. Huh. All right, next, what are we going to do? How many times does 2x go into 9x? Are we okay with that? I know it feels weird to say that, but it is. It's going to be just 9 over 2. So can we write plus 9 over 2? If you want to put 4.5, I'm okay with that as well. 2 times 9 over 2 should create 9x. And then what happens when you do 3 times 9 over 2? Do we trust him that it's 27 halves? So then we're going to put plus 27 halves. And then we're going to put brackets around it. And then we're going to subtract. And then we're going to end up with a remainder of, careful, minus 27 over 2. Ready? Now, can we rewrite this integral? So it's going to look like it equals the integral where it's 2x squared minus 3x plus 9 over 2. Now be careful. Minus, I'm going to write it ugly, but we'll clean it up. When you do the remainder at the bottom, isn't the remainder at the bottom always what you achieved over whatever it is that you're dividing by? So it's going to look like minus 27 over 2 over what it is that you're dividing by, which is 2x plus 3. This is what we're going to find the integral for. Okay. Some of this is really tidy. All right. Well, how do we clean this nonsense up? Yeah. So is it just 27 over 4x plus 6? Are we okay with that? So let's rewrite it. If you wanted to, could we rewrite it like this? I wouldn't normally do this, but could we rewrite it as the integral of 2x squared dx? Actually, I could even do better than that. Can we rewrite it as 2 times the integral of x squared dx minus 3 times the integral of x dx plus 9 over 2 times the integral of dx. And then the last one, interesting. Could I write it as, wait for it, minus 27 times the integral of 1 over 4x plus 6 dx. Is that okay, Marion? You want me to take the 2 out of the bottom? You want to be like that? Marion is suggesting, why do I not have the 2 here? And if that's the case, I agree with Marion. And then why am I doing this to myself? Can I not rewrite this as 2x plus 3? Better? I know, it's hard to work with me sometimes. Huh? All right, can we find the integrals of all of these pieces? Sure, why not? The first one is pretty friendly. It's going to be 2 hard bracket x cubed divided by 3 minus 3 times x squared divided by 2 plus 9x over 2. How do we do the last one? Is it arctan? I don't think it's arctan. You only want to use arctan, Magnus, if it's a dynamic function. 2x plus 3, despite its best efforts, not dynamic. Oh, the rate of change is changing. Because arctan is designed to work with dynamic functions. So here what I mean is if you let u equal, so you still have to do a u substitution, 2x plus 3, and then you're going to do du is equal to 2 dx. Can you see then that your replacement will be du over 2 for dx? And if I keep moving forward, and I'm kind of cheating a little bit, this is now going to turn into 27 over 4. And then inside of here, it's the integral of 1 over u du. Right? And then what's the integral of 1 over x, or the integral of 1 over u? What did you call it? So it's going to be 27 over 4, the natural log of the absolute value of u. And to save us some time, isn't that not just 2x plus 3? Yeah. And again, hopefully when I say dynamic functions, x squareds, x cubes, those sorts of things, they require more than just the natural log to make it work. Right? So, and then if it's okay, we'll put a big plus sign here. That looks like a multiplication sign. Put a big plus sign here, and then don't forget about the drowning child. So this is the solution. Now, we could clean it up. Why don't we clean it up? So it's going to be 2x cubed over 3 minus 3x squared over 2 plus 9 over 2x plus 27 over 4, the natural log of the absolute value of 2x plus 3 plus c. Minus 27 over 4. Thank you. You know what? We're going to go to like the super small eraser. Better. All right, that's number 8. Let's go to number 9. Don't these look really cool now, though? All right, number 9. Like we're putting all of your mad integrating skills on display. Number 9. Like we've been building towards this for like 3 weeks. Oh, Nelly. All right, here comes number 9. We have the integral of 2x upstairs. I'm not a huge fan of that. But then downstairs, we've got x squared plus 4x plus 8. This one's interesting. Dx. You ready? So I'm going to tell you, well, it's all over the place. My suggestion to you is this. If you were going to take the derivative of the bottom, what would the derivative of the bottom look like? So you can see that the top already has a 2x. If only the top was 2x plus 4, we would be gold, wouldn't we? Because you'd let u equal the bottom, take the derivative, perfect replacement. So why don't we just do that? You ready? So we acknowledge that this derivative is 2x plus 4. So if you don't like a problem, change it into a problem that you do like. So can we take the top and say 2x plus 4 minus 4? Isn't that the same as 2x? Now we're forced down this path because can we do long division? No. And at this moment in time, there's no u substitution that works directly. If we rewrite it like this, all of a sudden you can see how the derivative of the bottom can work with the top. Now, can we unmerge the fraction? In other words, could we rewrite it as the most favored version would be 2x plus 4 all over x squared plus 4x minus 8 dx. We love that guy because it's a u substitution. It's going to be a natural log. We're off to the races. Then can we write the other one as, you ready? I'm going to write it this way. Can I write it as minus 4 integral of 1 over x squared plus 4x minus 8 dx? It's plus 8. How did you know that? Oh, I started off with a plus 8. So this should be plus 8. This should be plus 8. This should be plus 8. Thank you for catching that. All right. So I'm feeling really good about integrating this. This is not a problem for me. I can do a use. You know what? Let's just do it. Let's get the points. Let's not mess around. Let's let u equal the denominator, the x squared plus 4x plus 8. We know that du is simply equal to 2x plus 4 dx. We did that by design. That's a perfect replacement. Our life is good. So the first part of this then could simply be rewritten as, well, do we still have to do du? What is du in this? Sorry. I did it correctly. Hold on. Just like you, I'm slightly distracted by all the joy that's happening in the building. So du is equal to 2x plus 4 dx. There's no more adjustment required. We can move on with this. It's just going to be the integral of 1 over u du. Hell, let's go all the way. Is it not just going to be the natural log of the absolute value of u? One more line, then it would be the natural log of the absolute value of x squared plus 4x plus 8. That piece of the puzzle is done. What about the other side? It will be arctan. What did you do to make arctan work? Did you complete the square? Or are you stealing Jason and Gary's technique? Is that what we're going to do? I'm okay with that. That doesn't bother me at all. So if we take a look at this side here, we're going to keep this as minus 4. This is the integral of 1 over. And can you see if you created x squared plus 4x plus 4 and then plus 4, if you split the 8 into the plus 4 here and the plus 4 there, can you see in a way you've kind of completed the square, except you just broke down the number 8. And if we move forward with this side of the question, you get -4, the integral of 1 over, I can change the order just for my own satisfaction. Put the constant first, plus, isn't this now just x plus 2, all squared? Now that we've got it in this particular format, we can see that a squared happens to be equal to 4. A itself happens to be 2. U squared is x plus 2 all squared. Therefore, u itself is x plus 2. But then don't forget that du will simply be the same as dx. Then if you wanted to, you could rewrite this as -4, the integral of 1 over a squared plus u squared du. It's going to be equal to -4 arc tan. Oh, I forgot something. Yeah, it's going to be -4, 1 over a. A is 2. Arc tan. And then the u value is x plus 2. And the a value is 2. So the natural log is the first piece of the puzzle. And then it's going to be -2. And then don't forget about the drowning child. What do you think about that, Magnus? Here it comes. Keep in mind, I'm going to give you a whole week off. Number 10. Number 10. Oh, I like number 10. Can you find the integral? Upstairs, you've got x plus 2. Downstairs, you've got the square root of 4 minus x squared dx. You can do it. I believe in you.
Yeah. Sorry for my class. You remember grade 10, guys? Some of you with me? Okay, so, oh, look at you guys.
That's what we're doing.
I go back into the fun room.
So there's different types of fun though.
I do enjoy this though.
Yeah, see? Okay. Thank you. Don't forget, we're going for ice cream.
Like the whole year.
Probably gonna be raining on that day, but we're going for ice cream. You guys are fine, okay? Make me pay for the ice cream? There's like 32 of you. I have to pull out a calculator. What do you think the average cost will be? Yeah, like $6. Holy Hannah. It's like $200. Jesus Murphy. It's up there with that Build-A-Bear. I told you guys that story, remember? Most expensive thing in history. Well, Jen, were you there for that story? Did you ever do Build-A-Bear at the mall? Like, oh, so my daughter's like 13th birthday. We decided to go to Build-A-Bear. And she had like 12 friends. So there's like 13 and 12. I just said, yeah, build any bear you want. Because I didn't know they were going to be like $50 to $60 a bear. I had to get a part-time job.
You have to work there.
Yeah, can I do some dishes? Not one of my brightest. My daughter was happy. Now here's the real question. So now my daughter is 25. So this is what, 12 years ago. How many of these Build-A-Bears are still in existence? Exactly. So we're going to break it into two separate functions. One really nice one and one that's going to be an inverse trig function, right? So if we unmerge the bottom, the first one is actually not too shabby. Because when you look at the relationship between the numerator and the denominator, can you see that looks pretty good, doesn't it? Plus, and then if you factor out the 2, can you see that the second fraction looks very familiar to one of our will be one of our inverse trig functions? How do you feel about this, Ethan? Pretty good. If we take a look at the first one, you're simply going to let u be everything underneath the square root. So it's 4 minus x squared. So du then will simply be minus 2x dx. And then if we divide both sides by minus 2, we can deal with the fact that we have an x in the numerator. So that's a nice fit for us. And then when we rewrite this, we could simply rewrite this integral here as minus 1/2 the integral of 1 over u du. And we can move forward. That will be the natural log in the near future. Okay, tell me what I did wrong. I love the faces. Should be square root. And if that's the case, can I save us a bit of time here? If we know it's supposed to be square root, can I just rewrite it as u to the minus 1/2 du? Better? Okay, that we can manage. No natural log required. Okay. Over here on the other side, I think we can see it. This is a squared is equal to 4. So a itself is equal to 2. U squared is equal to x squared. U is equal to x. And du is simply known as dx. That one we like. All right. And if I want to move forward with this, is it not just going to be plus? I'm going to write it as 2 arc sine. The u value is x. The a value is 2. That's not what the problem is. And I know I should probably not do them in pieces like this, but it's Friday before a spring break. Moving on from here, we can clean up the other one. It's simply going to be minus 1/2 Uh-oh. It's moving on me. That's a bad sign. -1/2. And then is it going to be u to the power of 1/2 multiplied by 2? This is not a good sign. I think the fact that I told my computer it's going to be spring break, it's deciding it may not work for us. Can you guys see it moving on the screen? Here. Okay. That's weird. Okay. Minus the square root of u represents 4 minus x squared plus 2 arc sine x over 2 plus c. Good. Can we do 2 more? We can do it. Like, don't you want to earn your spring break? Like, say to yourself, I got to spring break, I worked really hard, and now I can relax. Hey, here we go. Number 11. The answer to number 11 is a number. I want you to evaluate the integral from -2 to 2. In the numerator is dx, so that's not necessarily a bad thing. But then downstairs, you've got x squared plus 4x plus 29. Good luck. Use the Jason and Gary technique. You want to call it like the Gary J or the J Gary?
Gary.
The Jerry with the J? So are our bounds going to change if we do this properly? Aren't we supposed to add 2 to each one of the bounds? So you're going to write it as -2 plus 2 is better known as 0, and 2 plus 2 is better known as 4. And then you can write it as like du all over like a squared plus u squared. So it's going to be equal to, now we got to be careful. It's got to be like 1 over a arc tan of u over a as evaluated from 0 to 4. That's right. I'm just trying to make the commitment. I decided to work with you. I'm going to stick with you. But if you realize that we can see if I'm the same as the values that you get. Okay. So if we move forward from here, do we know what A is? Which one do you want to go with? Not nice of me to make, because how many mistakes, we won't talk about that. So could we then just simply rewrite this as equals 1/5? Because we could put the 5 in, that's not the issue. But I'm going to still keep it as arctan of u over 5. Still evaluated from 0 to 4. It's going to be the same. Okay. And then when we use the fundamental theorem of calculus part 2, it's going to be the upper bound. So the upper bound would be 1/5 arctan. It's a shame that this isn't one that we recognize. That's a shame. Arctan of 4/5 minus 1/5 arctan of 0 over 5. Well, this one we actually know, because what's the angle that goes with a tan value of 0? 0. So truly then, if you go through this, you can use your calculator, and all you're going to have to do is you can type it all in, except your calculator obviously doesn't have arctan. So you will use tan inverse. Here's the good news. Your calculator knows the restricted domains. You don't need to tell it. So what's the final answer? Perfect. Final answer should be 0.135. Good. You ready? You ready? Number 12. Yeah. Number 12. So when I release this video to Dorsa, do you think she'll like it? She'll give it a thumbs up. Okay, here we go. Last one. The integral of x divided by the square root of 9 plus 8x squared minus x to the 4th dx. No thumbs up for this? Like, I'm going to tell you it's arc sine. It is arc sine. And if it's arc sine, it's got to be a squared, right, minus u squared in order for it to be arc sine. Okay, you guys work so hard today. I'm gonna help you. Okay. Can we sort of change the order so we can focus in a little bit better? And so I'm going to rewrite it as minus x to the fourth, which by the way is super cool because it's going to help us later on with the numerator, with the x that's standing in the numerator. So that's a good thing. So I'm going to write it as minus x to the fourth plus 8x squared plus 9. So I'm just manipulating what's underneath the radical. Then you know what I'm going to do is I'm going to factor out the minus sign. Okay, and when I'm going to factor out the minus sign, I'm also going to complete the square. And what I mean by complete the square is I'm just going to manage these pieces right here. I'm not going to worry about the 9. The 9 is not my problem. All right, so I'm going to factor out the minus sign. This is going to create x to the fourth plus, sorry, x to the fourth minus 8x squared. And then I'm going to complete the square. So you got minus 8. So divided by 2 and square it. You're going to add in 16, and then you're going to wrap the bracket around it. That will factor into something really useful for us. However, you didn't add in 16. You actually subtracted 16. Because of this minus sign that you see hanging around here, you actually subtracted 16. So to offset that, you're going to add 16. And then don't forget about the 9 that's sort of just hanging around. Then, when you collect your pieces, you're going to collect the 16 and the 9 together. Conveniently, that happens to be 25. Minus, this will factor into x squared minus 4. Better? Now, when you rewrite the integral, you can rewrite it as the integral. X is still safe upstairs. And now it's the square root of 25 minus x squared minus 4 all squared dx. Now can you see it will be arc sine? You know that a squared just happens to be equal to 25, so a itself just happens to be 5. That's not the problem. You know that u squared is equal to x squared minus 4, and as Gary reminded me, squared. Therefore, u itself just happens to be x squared minus 4. Du happens to be 2x dx. Therefore, du over 2 is exactly x dx. So if we organize this correctly, we're going to have to factor out the 1/2. And if you want to, you could rewrite it as the integral of du over the square root of, and if we follow this path, I guess it's a squared minus u squared. It's going to be 1/2 arc sine. What is u? X squared minus 4. What is a? 5. And then don't forget about the drowning child. Do you want your homework? It's only like 31 to 41 odd. Here it is. So 5.7 page 385, numbers 31 to 41, O double D. Thank you for your patience. Thank you for your hard work. I appreciate it. Work hard and enjoy your spring break, please.